Hello everyone, and welcome to the fourth video in our series on research methodology, titled Conducting Research. I am absolutely thrilled to have you here with us today. You know, if you've ever looked at a massive scientific breakthrough, or maybe a major policy shift, or even a brand new technological innovation, and you've found yourself wondering about the exact mechanics of how they figured it all out, well, you are in the exact right place. Today, we are framing the topic of conducting research not as some dry, boring administrative requirement, but as an epic, highly structured quest for truth. It is quite literally the backbone of human progress. Think about it. Every single medical breakthrough you rely on, every algorithm that shapes your digital day, and every sociological shift we've come to understand, it all started as a structured quest for truth. So let's dive right into this and uncover the blueprint behind human discovery.
Here is our map for today's journey. We're going to cover 1. The quest for knowledge. 2. The 8-step blueprint. 3. Choosing your methodology. 4. Ethics and research. And finally, 5. Challenges and sharing results. Let's get to it. Section 1. The quest for knowledge. Before we examine the how, we really need to establish exactly what this quest entails.
To start, the actual origin of the word itself is super fascinating. The word research comes from the old French word rechercher, and this literally translates to seek out or to search again. I really want you to focus on that second part for a second, to search again. This brilliantly captures the entire philosophical essence of science and academia. It tells us that our understanding of the world is never truly fully settled, right? It is constantly being refined. Research is an active, ongoing quest. It's about looking at a totally established paradigm, and then looking deeper, analyzing it critically, and continuously challenging what we think we know. It demands a highly systematic effort to investigate, verify, and interpret data to solve complex existing problems. It's not just a passive collection of facts, it's a dynamic pursuit.
So why do we even embark on this quest in the first place? Well, the purpose of research is incredibly multifaceted, fundamentally aiming to expand human knowledge and test existing theories. We can actually break this down into 4 main categories. First up, we have exploratory research. This seeks out entirely new frontiers where you currently have very little information. Think of things like the initial, groundbreaking investigations into deep-sea hydrothermal vents. Then there is descriptive research. This aims to systematically map out the specific characteristics of a phenomenon. A great example is a national demographic census, where we are just trying to get an accurate picture of what exists. Third is explanatory research, which dives deep into the causes and effects to understand exactly why and how variables interact. This is like analyzing why specific interest rate changes affect global inflation. And finally, we have applied research, which takes all this seeking and focuses it on solving real-world problems right now, like engineering a more efficient solar panel to provide immediate practical benefits to society.
To really ground this, we can look at 2 vastly different applications that are both driven by the exact same fundamental quest for knowledge. Over in the medical sciences, a researcher's problem might be heavily applied, for instance, studying the clinical efficacy of a brand new, potentially life-saving pharmaceutical compound. Now, on the flip side of the coin, in the social sciences, a researcher might be doing explanatory research, exploring the granular, messy nuances of social media's impact on collective mental health. These are 2 totally different fields, right? One is literally looking at cellular responses in a tiny petri dish, and the other is analyzing massive amounts of human behavioral data. Yet they both rely on the exact same foundation. They both require forming a rigorous hypothesis, meticulously isolating variables, and subjecting findings to intense peer review to make decisions that ultimately affect all of us.
Okay, moving on to Section 2, the 8-step blueprint. Let's look at the logical sequence that structures our quest. Conducting research isn't random. It's a highly structured endeavor. Phase 1 is all about design and setup. It starts with Step 1, identifying the problem. You need a question that is absolutely clear, researchable, and significant in its scope. Step 2 is reviewing the literature. And listen, this is a critical moment. You aren't just skimming past papers, you are actively hunting for the literature gap. For a researcher, finding that gap is like finding the Holy Grail. It is the specific pocket of the unknown that their work is going to illuminate. This ensures they're actually pushing the boundaries of human knowledge outward rather than just duplicating work someone else has already done. Step 3 is formulating the hypotheses, or your main research questions. This is where you create a testable statement that predicts the relationship between variables. And finally, Step 4 is research design and methodology. This is where you carefully select your tools and plan exactly how you are going to collect and analyze your data, effectively establishing the strict validity and reliability for your entire study. You have to get this right, or the whole thing falls apart. So once that battle plan is firmly set, we move to Phase 2,
execution and reporting. Step 5 is data collection. Now, depending on your field, this could mean running highly controlled laboratory experiments, conducting multi-year longitudinal interviews, or even extracting data from dusty historical archives. Step 6 is data analysis. Because raw data, it's really just noise until you give it some structure. Depending on your method, this might involve running complex multiple regressions in specialized software like SPSS, or maybe conducting rigorous thematic coding in programs like NVivo to pull underlying patterns out of hundreds of hours of interview transcripts. Step 7 is interpretation and conclusion. This is the moment you connect your analyzed findings right back to that original hypothesis we established in Step 3. You synthesize the significance, and this is very important, you honestly acknowledge the limitations of your work. Nobody's study is perfect. And finally, Step 8, documentation and reporting. This is compiling the findings into a formalized paper or presentation so the broader academic community can scrutinize it, try to replicate it, and eventually build upon it.
Section 3. Choosing your methodology. Let's talk about the specific tools we use to investigate these problems. Now we get to look at the classic face-off in research, quantitative versus qualitative. A really good heuristic here is that quantitative research typically answers the questions how many or how much, while qualitative research seeks to answer why and how. Quantitative research is all about the hard numbers. It involves measurable outcomes, strictly structured instruments, heavy statistical analysis, and it places a massive emphasis on objectivity and replicability. Qualitative research, in total contrast, focuses heavily on the human element and the narrative context. It seeks to understand subjective meanings, complex lived experiences, and messy social dynamics. So instead of sending out a simple Likert scale survey, a qualitative researcher might use long-form ethnography or deeply detailed case studies. It is absolutely invaluable in fields where a simple statistical output just cannot adequately capture the full human story.
But here is the thing. Modern researchers often don't want to be strictly limited to just one side of that spectrum. And this brings us to mixed methods research. This approach integrates both quantitative and qualitative methods, which introduces a truly vital academic concept known as triangulation. Triangulation is essentially the practice of using multiple methods to cross-verify your findings, ensuring that the inherent weaknesses of one method are perfectly balanced out by the strengths of the other. It's a real game changer. By combining the hard numbers and statistical objectivity of quant with the rich narrative context of qual interviews, researchers achieve an incredibly robust, reliable perspective. It gives you both breadth and depth, making it increasingly essential in complex interdisciplinary studies where you really need a comprehensive 360-degree view of whatever phenomenon you're looking at.
Section 4. Ethics in research. Let's shift gears and talk about the moral code of the researcher.
I cannot overstate this. Ethics is the absolute cornerstone of conducting research. A study can have flawless, brilliant methodology, but without a rock-solid ethical foundation, the work is totally invalid. The foundations of this moral code are strict, and they largely stem from cornerstone documents like the Belmont Report, which outlines 3 core principles: respect for persons, beneficence, and justice. Respect for persons mandates informed consent. That means participants have total autonomy, and they know exactly what they are signing up for, no tricks. Beneficence is the researcher's absolute, unwavering obligation to maximize possible benefits and minimize any possible harms, protecting confidentiality at all costs. Justice requires that the burdens and the benefits of research are distributed fairly across all of society. Furthermore, institutional review boards, or IRBs, provide the necessary systemic safeguards to actually enforce these rules before any study is even allowed to begin.
And we have to remember that these rigorous rules exist for a profound and, frankly, very dark historical reason. Ethical lapses cause deep, lasting harm to individuals, and they fundamentally fracture the public's trust in science. The historical gravity of the Tuskegee syphilis study stands as a stark, horrifying reminder of the catastrophic human cost when researchers decide to prioritize their own curiosity over fundamental human rights. It was tragic watershed moments exactly like this that necessitated the creation of the rigid, uncompromising ethical frameworks we use today. It fundamentally changed institutional oversight forever. These guidelines and review boards, they're not just annoying administrative red tape, they're the vital, non-negotiable protections that keep the pursuit of knowledge humane, accountable, and just for everyone involved.
We've reached Section 5, Challenges and Sharing Results. Let's look at the final hurdles. Even with perfect planning, there are always dragons to slay on this quest. Let's look at the systemic hurdles that constantly threaten to derail research. First up, limited resources. There's often a stark reality of insufficient grant funding, lacking equipment, or just not having enough manpower to execute the ideal study design. Second is access to data. Researchers might struggle for months to recruit specialized demographics, or they might be totally blocked from accessing proprietary closed archives. Third, you have intense time constraints. These are usually driven by strict academic deadlines or funding cycles, which can really pressure researchers to rush their process. Fourth is the constant, rigorous battle against bias. This includes confirmation bias, where a researcher might unconsciously favor data that supports their own hypothesis. It also includes phenomena like p-hacking, which is basically tweaking or manipulating the data just enough to produce a statistically significant but ultimately completely false result. And finally, rapid technological change means methods can become obsolete overnight. Overcoming these deeply systemic challenges requires immense methodological rigor and a lot of adaptability.
Now, let's say a researcher successfully navigates all of those hurdles. The quest still isn't quite over, because the ultimate impact of research lies in its dissemination. Doing all this brilliant work and then just hiding it in a desk drawer helps absolutely no one. Researchers must share their findings by publishing in peer-reviewed journals, presenting at global conferences, and engaging directly with policymakers. Today, we're seeing a massive, exciting shift toward the open science movement and open access publishing. There is an ongoing, vital debate happening right now about why publicly funded research should ever be kept hidden behind expensive journal paywalls. Open access radically widens the reach of academic work. It democratizes the data and ensures that brilliant discoveries are accessible to a global audience, so the research truly benefits society as a whole, exactly as it was meant to.
Conducting research is intricate. It is highly rigorous, and it is undoubtedly intellectually demanding. But, as we've seen today, it is the fundamental engine driving human progress forward. It shapes our technological innovations, our public policies, and our very understanding of society itself. So, I want to leave you with this final provocative thought. How will you apply this blueprint to your own quest for knowledge? Thank you so much for joining me today for this explainer. If you found this valuable, please do me a huge favor. Hit that like button, drop a comment below with your thoughts or questions, share it with a fellow learner, and absolutely make sure you subscribe to the channel so you never miss an update. Keep seeking, keep searching again, and I will see you in the next one.